Blinky blinky. Potentiometer. Here's the code. Here's the page. RGB LED. Okay, we got red, green, blue. Red, green, blue. And then we each go to the pins. So red on the left, ground, and green and blue on the right. Page and code. Here. Multiple LEDs. $100 resistor for each LED, each going into its individual digital pin. And here's the page, here's the code. This is push button with an RGB light. So I'm using 10K and 3 100 ohms into the digital pins, and then you get the 3.3 and ground rails. This is the page, and this is the code. This is single pole double throw switch. So in that position, the green one blinks. I switch it, red one blinks. Using 100 ohm resistors and digital pins. I'm not using this right now, it's just another thing. So red, green, red, green, red, green. So here's the example page, and here's the code. This is photoresistor. So when cover the photoresistor, LED turns on, off, on, off, on, off, on. And here's the page, and here's the code. Oops. So this is potentiometer controlling an RGB LED. So we have the 3 potentiometers controlling red, green, and blue. So as I turn down one of the colors, the main color of the LED changes. So that would be blue. If I turn down blue, and turn up green, then turn up red, can make different colors. There's purple, which is blue and red. And, yep. So that's the page, and there's the code. And yep, so it's just these three are analog inputs going into the analog pins. Then it changes the values of the digital outputs for the PWM values for the RGB LED colors, which is red, green, blue, to make any color I want. So this is the temperature sensor. I had to tweak the code a little bit because before it was saying my room was 30 degrees, which it's definitely not. And you get degrees. So it basically measures the temperature, and as the temperature increases, the voltage increases, and that gets scaled to degrees in Celsius and degrees in Fahrenheit. And right now, if I put my fingers on the sensor, I make it warm up, and you can see the value is rising for Fahrenheit, degrees, and the voltage. Yeah, so what I did to tweak the code was increase the temp val, which is the analog input, which is around like the voltage, and this used to be 3.5. That gave me around 30 or so degrees Fahrenheit in my room, and I increased it to 4.85, which is it calibrated it roughly with another temperature gauge to around 68 degrees, because that's what it actually is in my room, and it seems to work good now. That's the sensor right there, and then we got the 3 volts in, then to ground, then the analog output, analog input through that, and that's it. So this is my servo, single servo. So it uses the PWM value from the digital pins on the Arduino, 5 volts, ground to control the servo. I used a different servo than the one that was in the kit just because this one's, I think, is better for an example. I would have used this like on a remote controlled plane or drone or whatever to control like a control surface on the plane. So yeah, and it basically just changes directions based on the degrees that the servo library and the Arduino IDE tells it to go to. So it just sweeps and goes 90 degrees, 0 degrees, 180 degrees. There's the page, the code. So this is controlling a motor using an NPN transistor, which allows current to flow when a small voltage is applied to the base, and that allows current to flow from the collector into the emitter to go through the system. And when there's not a voltage at the base pin, it doesn't allow current to flow through the collector and emitter. So, got a geared motor and 100 ohm resistor going to the base of the NPN transistor, and then that goes around the motor back to ground on the Arduino. and there's also a Zener diode or flyback diode, as the tutorial calls it, and that prevents the motor from damaging the transistor when it turns off, when it turns off, it creates a spike in voltage which can damage the Arduino. The diode prevents that. Yeah, so plug ground into it. The motor turns on for half a second and off for 0.8 seconds, which I changed. It used to be 3 seconds on and off, but I changed it just because I wanted to. On time, off time. It's the rest of the code. And here's the page. And good motor off, on a second, off a second, or on, off a second, off 28 seconds. Yep. So this is the SparkFun motor controller. So plug ground in. This board allows me to control forward and backward motion of the motor, because it has a special 8 bridge, which is just 4 transistors, 2 NPN and 2 PNP, that allow me to control the polarity of the motor, so I can go reverse and forward. And I can also do a bunch of other things. So I'm just using digital pins to set the settings on the control board. So here's the page, and here's the code. Yep. So this is the motor controller, but with speed and direction control. So by increasing the potentiometer, change the speed, and by hitting the switch right here, changes directions. Slow down, speed up, forward, backwards. This page, and we got the code. So this is using the piezo buzzer to make music, I guess, and just like different tones. So we got the big piezo buzzer. I used the big one because I'm using the little one on another project. So if I reset the Arduino and press this button, it's very loud and it makes music. So this button just circulates the circuit, and when I let it go, it mutes it. So if I redo it, it's cool. Yeah. And the page is a little bit misleading because, yeah. So yep, that's the page, and then here's the code. So you can see the different frequencies it uses to make that little song. That's the pin the buzzer's on, and you can change the tempo. So say I turn up the tempo to like 75, which should speed it up, and upload that. So the tempo changes the rate at which the song plays, so 75 instead of 275, so it'll play it a lot faster now. So if I reset it, plays a lot faster. Yeah, that's pretty much it. So this is the sound detector. It uses the RGB light to detect how loud a noise is. So kinda loud, or like normal, is blue, louder is green, and loudest is red. So if I make a loud noise, it turns green. If I make an even louder noise, it goes to red. It's hard to get it to go to red. But you can see it if you look for a second. And there's a microphone here. And if I tap on the microphone, you can see it. And a signal right there. And then it just goes through the envelope. That is what detects the sound. And that goes to the analog input. And depending on the intensity of the sound, it changes the color of the RGB LED from blue to green and to red. And there's the page, here's the code. It uses different cases to signify if the sound is loud enough to turn the next LED on in the RGB LED. And that's it. So now I'm using the shift register IC to control the sweeping of 8 LEDs. This goes back and forth like that, each having their own 100 ohm resistor, and they all go to one of the pins on the IC. And then 3 of the pins on the IC go to the Arduino, and they're the data pin, the clock pin, and the latch pin, which of course controls how the LEDs blink, go off and on in this pattern. So this is the page. There's the IC. Yep. And then here's the code. And you can change the delay time and all of that. Yep. So this is my example of the LCD screen. So I get a readout of the distances of the LiDAR sensor. So that's between there and the wall over there. And I add it in centimeters, meters, inches, and feet. So right there. And then I put my hand in the way. Decreases a lot. Yep. So now I'm using the built-in accelerometer in the 101 to control a motor. And I'm just using the motor driver or the motor controller to like read when the accelerometer is that far over, turns the motor on. Use the page for it, and then this is the code. So once the accelerometer has reached a certain threshold, the motor turns on. So now I'm using the Arduino 101 as a tap detection. So if I tap the Arduino, it'll blink the LED because it detects that using the accelerometer. So blinks. Yep. And so this is the page for the thing. Using the RGB LED as a detection thing. And then there's the code. That's it. So I have the LCD with the date and time on it, with the LCD on the 101, because that's one of the features it can tell the date and time with the 101. And that's it. It's actually January 3rd, but I said it as January 1st. This is the page. And the code. Actually, I set it so that it would be the actual time. And that's it. So now we have the Bluetooth that I can connect to over the Arduino One, and it just turns the onboard LED on and off. So I'm just powering it off the battery, so there's no connections to the computer. So if I go into my Bluetooth capable smart device, I can connect to the Arduino and then upload a command at 01, meaning on. So I send that and the onboard LED turns on. And then I can do 00, send that, and it turns off. So turn it on. Oops. I turn it on again. You can see it goes on using this. And I can also use the download or read function by pressing that. And if you look at the value, it registers that it's on.